basically with this problem, you first have to take the fraction and factor the bottom. And now I did. And now the problem is, this started with two separate fractions added together. And what happened is common denominators were found, and then the top was found and simplified. So let's take the factored denominator as two separate fractions and try and think about what were those two separate fractions. We know the final addition of them adds up to 5x minus 10, but we don't know what they were prior to that. So the best way to do that is to call one A and one B. And think about, if I had to add these two fractions, I would need common denominators. On this one, I'd need to multiply the top and the bottom by 2x minus 1 over 2x minus 1. On this one, I'd have to multiply the top and the bottom by x plus 2 on both the top and the bottom. Now, when I do that, I get one fraction that has the bottom 2x minus 1 times x plus 2. But I have all of this stuff on the top. I have a times 2x, which is a, which is 2xa. Let's write that, 2xa. And then I have a times 1, so minus a. And then I have b times x, so plus bx. And then I have b times 2 plus 2b. Now, at this point, what you need to do is rearrange the top of the fraction, combining the parts with the x together and then the parts without the x. So, if I rewrite that top, I'm going to go 2ax plus bx minus a plus 2b. So all I did was rearrange the top, and I'm not touching the bottom at this point. Now, if I look at this part of the top, I see that they both have a common factor of x. So I can factor that out and call that x times 2a plus b. And I still have the last part, minus a plus 2b. Again, the bottom is the same, so I'm not going to write it. Now, if you compare this to the original top that I had, it's 5x, but this is 2a plus b times x. So that means that the 5 and the 2a plus b must be the same. 5 equals 2a plus b. And that means the minus 10 part has to equal this other part. So minus 10 has to equal minus a plus 2b. And now, to solve that, it's pretty much straightforward. You can solve it as a system. I could multiply this whole system by 2. And if I do, I get negative 20 equals 2a, negative 2a, and then multiply that by 2 plus 4b. And if I do that and add them, the a's cancel out. So I end up with negative 15 equals 5b. Negative 15 equals 5b. So b, if I divide by 5, is negative 3. Do you agree with that? And if b is negative 3, I can go back and now I can find a, right? I can go back to any one of these originals. So if b is negative 3, I could go here, add it to both sides, and get 8. And I could say 8 equals 2a, and a equals 4. So what were these two fractions? We can go back up here, and this one was a over x plus 2. Remember I said that was a and that was a b? So I could say that this was 4 over x plus 2 plus negative 3 over 2x minus 1. And if you multiply that out and add the denominators, you should get 5x minus 10 for the top. and it will work. This is called solution by partial fractions. You will learn it again next year in pre-calc. So, good luck. So, and I need to figure out what were the real tops of the two original fractions. So now I'm going to just do a little arithmetic here, multiply out, so 2xa minus a plus bx plus 2. Now I'm going to regroup. I'm going to group like terms together, so the terms with the x's and the terms without the x's. So, and if you had x squared, you group the x squared terms together, the x terms together, the plain old numbers without x's together. All right. So on this one I get 2xa plus bx minus a plus 2. All right, now I'm going to factor, if I can, each group. So this group factors out x, and then inside I'm left with 2a plus b. Now when you do factor out the variable x, don't ever factor any of the coefficients with it, even though you could, if you could. For example, if this was 4xa plus 2bx, I could factor a 2 out under normal factoring conditions. Do not factor the 2 out when you're doing the partial fraction. So you just want to factor out the variable. So now I have minus a plus 2. Now, if I take this and think about what's going on here, 5x minus 10, if this equal sign is indeed true, and it is, it's telling us that this side does equal that side. If that's true, the x terms have to be the same. So 5x has to equal x times 2a plus b. And if that indeed is true, the 5 must equal the 2a plus b. Because if that was a 5, I'd have 5x and 5x. So that becomes a little mini equation to solve. 5 equals 2a plus b. Now, the other mini equation, the constant term negative 10, has to equal whatever negative a plus 2 is. So there's another mini equation. Negative 10 equals negative a plus 2. Now, at this point, I want to solve this system of linear equations. It's pretty easy to solve. I could just add them together. But then I notice that I could solve for a, right? And do you see what happens when you solve for a? Here? So now I do a little simplifying here. So I get 2ax minus a plus bx plus 2b. I'm going to rearrange so that I have like terms with the x's together. So I'm going to have 2ax plus bx minus a plus 2b. At this point, I'm going to factor so that I have the x factored out here. So I have x parenthesis 2a plus b. Nothing common to factor out here, so I'm going to just leave that as my constant term. Now again, remember we're comparing the top. So if this top indeed equals this side here, that means that the x term has the coefficient of 5 here, so this part must equal 5, because 5x has to equal 5x, negative 10 has to equal this part here. So I have two little systems to solve. I can say 5 equals 2a plus b. And I can say negative 10 equals the constant part, which is minus a plus 2b. Now at this point, you know how to solve systems, right? So you can just solve this system. I would multiply, maybe I'll multiply the top by 2. And if I do that, right, no, I'm going to multiply the bottom by 2. So if I multiply the bottom by 2, that way I don't have to change any signs, because 2a and minus 2a will cancel out. So I'm going to rewrite this as 5 equals 2a plus b, and the bottom becomes negative 20 equals negative 2a plus 4b. The a's cancel out, so I get negative 15 equals 5b. So I get b equals negative 3. You with me so far? Now, if b is negative 3, I can go back here. 2 times negative 3, negative 6. Add 6, right? Oh, whoops, b is negative 3. Negative 3 here, add 3, I get 8. 2a equals 8, a equals 4. So b is negative 3, a is 4. You can do the arithmetic out for that if you want. So, what were the original fractions here? They were 4 over x plus 2 plus, what's the b? Negative 3 over 2x minus 1. Now, if you're working or checking with somebody else who's doing the homework, you may come up with different a's and b's, but your final answers will be the same. Somebody else might have put the 2x minus 1 first. And if they did, their a is going to come out to be minus 3. In the end, your two final fractions should look the same. So I think you can handle this. Good luck with the homework.